Many times, a project manager prepares a schedule, and the client's or the management's first comment is that the project is needed to be finished in half the time. Well, maybe not half, but will be asked to create a schedule that finishes the project earlier. The current schedule is too long. It is also possible that there may be an external deadline to meet. For example, regulations have changed, so certain stuff has to be ready before the deadline. Otherwise, the government may impose penalties. Resource shortage or non-availability could be another reason. Extreme cold weather, snowfall season could be other time-related challenges. And certain work needs to be finished before the seasons set in. So there can be many reasons to cut the schedule short. The schedule can be shortened by reducing the scope of the project. But what if that is not possible or acceptable? In such a case, the schedule compression techniques can help. Schedule compression is a way to shorten the schedule and get the work done earlier, but without cutting down any scope. One compression method is called crashing, which is shortening the schedule by engaging additional resources, making the resources work overtime or over the weekend, or paying an incentive to a seller to finish the work earlier. Crashing in most cases will result in an increase in cost and can sometimes result in increasing the risk. Remember one thing, that critical activities should be crashed first. What is the value of crashing an activity that already has float available? It will increase the float without any impact on the critical path. So always crash critical activities first. It is possible that when critical activities are crashed, some non-critical activities may become critical. If further crashing is needed, then those can be crashed. The other method is called fast tracking. A schedule is fast tracked when work is done in parallel. Instead of waiting for activity A to complete and then start activity B, B is started earlier before A is complete. The overlap reduces the time to finish the set of activities, though each activity is still taking the same amount of time. Overall, the project schedule will be fast-tracked this way and will get shortened. So for example, complete design and then construct. Why wait for the design to be 100% complete before construction can start? Say construction can start once 50% design is done. By the time the remaining 50% is completed, construction is well on its way. The challenge is that what if there is a design update to the already completed 50% design because some changes happened in the later part that necessitated the change? That is the risk inherent in the fast tracking approach. So fast tracking typically increases the risk of rework, which may also result in increased cost. Not every piece of work can be fast tracked. Usually, preferred dependencies can be fast-tracked. Mandatory dependencies may not be fast-tracked at all, but in some cases, only a small fast-tracking can be achieved. In the example shown, 25 days of work. If fast-tracked, duration reduces to 15 days, and if crashed, it is reduced to 13 days. Fast tracking is resulting in overlapped work, which increases risk, while crashing is resulting in adding more resources, which results in a higher cost.